Not yet. I have no idea. I'm thinking
about that one. Jen and I talked, she's about 45 minutes.
This kid's not.
And we thought about being close to one another, that the next thing,
There's so many
2 and 3 have to be a teach and a reteach.
Yeah.
We would tie that together.
Oh, that'd be cool.
Either she can come, go on first, the other person can go watch. She wants me to go first, I can go watch her, so I'm going to have a real idea of what the reteach needs to be, because there's some videos.
Here, see. Got book bags along the back if you don't mind, just so they're out of the way. You will, of course you need pencils.
What do you think?
You did not need your books today. That's right, you had to bring them with you, you're good. Aww. Get some farm space in there. Pick a seat, I'll pick them for you.
Right, you're sitting next to me.
Kaylee and Rucker, up here.
What?
Psych. No, I want to go right here.
I'm picking your seats. Books and bags off the back, let's go.
What are you? Just the pencil.
Pencils and notebooks, that's it.
Oh.
Kaylee, you have to be a 3. Rucker, you have to be a 3.
Okay. I was sitting there.
Alright. Bags in the back. Let's go. Get back to your seat.
You gotta sign it.
You should be prepared for class. Bags in the back. Take a seat. Let's go. I'll pick them for you in about 30 seconds. Guys, if you take a notice, the computers that you have, they're not recording right now. Okay? So I'm going to have Haley, Amanda, Bella. No, that's, don't touch the stuff that I told you not to. No. So now, Juan, over there.
Juan got evicted.
Haley.
Sorry, man.
Please.
Thought that had to happen.
Jared, over there. Do not touch the computers because I have them set up the way that I want them set up. Also, please take notice. No, over there. So remember we talked about being a 3?
Oh,
Being
yeah.
a 3? Okay. So, Bella, Amanda, Haley, Juan, and Kaylee, you guys are going to be in control of the record button. The computers that you have open right now are not recording. Okay, they're also directed so they're looking at your work as opposed to your faces. Okay, so you don't need to freak out. It'd be weird. So now the only thing I do kind of want you to try to emphasize as much as you can is in your conversations, and the mics are all hooked up so that they can hear you and hear your conversation. Please try not to South Philly talking, go through all so fast, only Piney talks, okay? Make sure you are deliberate in what you're saying. The microphone will catch it, whatever you're saying, and if you find something that you're like, oh, well, take a look at my work. If you don't mind, just kind of throwing it up to the computer, the microphone, the camera, and then talking to your group as well. Okay? A little bit of a show, but it'll save me a lot of editing work later. Okay, right now we do have a warm-up. Took us a little bit to get there. In your notebooks, this is independent. The image is as dark as you can get it. I want you to come up with as many possibilities that can work.
Are we recording right now?
No, we're not recording right now. I have the main recorder going on. So, you have stick figures, yeah? You're going to see that some movements will work and some movements won't work. I want you to try to find as many movements that do work and tell me how. Where's your notebooks? Okay, go. Independent, this is just on your own. This is your own warm-up. This is getting our brains thinking about transformations.
Is there an original figure?
Yeah.
Any of them.
Okay. Then we just list which ones will work.
Any of them. I would prefer to use pencil in math class.
Are we allowed to use more than one
Absolutely.
transformation to get
Is there more than one transformation to use to get a pre-image to an image?
No.
Yeah. An eraser? You can call yourself an athlete. See, Riley will die for this one. She didn't have to. You grabbed my fingers. Got you. Come up with as many as you can. Sorry. Got one?
No, I'll see something else. And then I realized.
I like how some of you guys are organizing your paper. Okay, so something to think about in the next minute and a half. Which paths are impossible? See how many you can come up with. Which pathways are impossible? Impossible. Oh, you already did. Oh. Explain that to me. Oh, you clarified this as your original movement. Does that only have to be your original movement? So like what happens if I said like figure D is your first one? Impossible. Okay. All right, about another 30 seconds or so. What you got? What's like worse for you? If like this is harder to see, or if like this one's harder to see? Okay. Levanta las manos, por favor. Tell me who decided on an original figure? Who decided for themselves that they're like, you know what? A is going to be my original figure. Why? Why did you do it, Karen? Boom! Yeah, come on.
Better see the translation.
It'll help you better see the translation or the
The
transformation. Okay. How many of you did, or who did not decide on figure A as being your original figure? You didn't pick A to be like an original figure?
Like I used it to start, but I didn't use it consistently throughout.
Ah, you didn't do that either? So how many pathways are possible? Let's start building a list. Let's start building a list. How many pathways are possible? Is that possible? Yeah. All right, cool. Go.
A to B.
A to B. Is A to B possible? Do we agree? Disagree? Agree? How? How is that possible? Rotation. Where would the center of rotation have to be?
The middle, right, like right below.
Where would the center of rotation have to be if A to B is a rotation?
In between the arms.
In between the in between the arms?
Yes.
Yeah. No, I think
No,
it would be
the
like
center of the body.
The center of the body, yeah, that's what I'm saying.
So like
Yeah.
Yeah.
right there?
Yeah.
Huh. What about if we were taking it very realistically? What if I said, here's my piece of paper, this is my transformation, where would the center of rotation have to be then? So if this is my coordinate plane,
That would be the origin.
so like right here,
Yeah.
why?
Because they're evenly distant.
Because what are we trying to maintain? Equidistance from the from the, which give me a better word, give me a better term for that point, Kaylee. Not the origin, doesn't have to be the origin. The vertex, it's a three-word term. No, line of symmetry.
The point of rotation.
What?
Center of rotation.
Center of rotation.
Okay, but yes, you all are right. You all are like, the vertex, the origin, the center. Okay, yes, I agree. Let's focus on our vocabulary. All right, so give me something else other than starting with A, other than going to B. Give me another transformation that works.
E to F.
E to F. All right, so let's go from E to F. I apologize, it's a little bit hard to see on the board. But how is E to F possible? Who said, I heard it's not, why, Jared, do you say it's not possible? So E to F is not possible?
Because it's the, I don't know, it's the same image, but the arms are like, you can't do that.
So, I want everyone to hear it. I'm a little bit louder so the microphone can shut.
I said, it's the same image, but the arms are flipped, and you can't do that.
You can't do that.
They're not the same.
They're not the same image, all right? So they're not the same image, or the image is not a result of transformation from the pre-image. Okay, so I agree it is impossible. Do you understand the, yeah? Okay, find me one that is possible. B to F? How so, Miss Waldron? Would it be another rotation? Haley, what do you think?
Yeah, rotation.
A rotation?
Yes.
Juan, what do you think?
Yeah.
Could it be a reflection?
No, it could be.
No, it couldn't, because
Ben, what do you think?
Because the arms are different. Like the left arm is like when you reflect it, it would be closer.
So if I were to reflect this here,
Yeah.
what would have to change?
Everything.
The arms would have to change.
And the legs.
And the legs. So Jared, go for it.
It could be two reflections.
How so?
You reflected it, like, I don't know, like this, say over the, say that's an x-axis, if you reflect it over the
So if I give it, so if I reflect it over the x-axis, so then what my figure's gonna look kind of like this guy, that guy, that guy.
Yeah.
Ah,
And
okay.
then
Wow.
you can reflect it, like, again, just like that.
So give me.
I don't know.
No.
You can,
Okay, so you told me that this was the x-axis, and sure, we can make that up, or we can say that it's a horizontal line, correct? Because it doesn't always have to be an axis. Okay, so then how would I take my intermediate image and get it to my final picture? Where would the what have to be where? Stay on thinking. I'm going to go to Capriati. The center of its body. So give me descriptive words.
Like, if you had a rotation point in the middle of its body, and you
Rotation point in the middle of its body. So I
No.
just kind of throw this guy on like on a rotating
No, like,
loop.
I meant like to flip it. I don't know.
So what word associates with flipping? Okay. So with a reflection, what do I need? Line of symmetry. Where would that line of symmetry? It was just reinforcing what Jared was thinking. How do I take my red picture to make it into my eraser's work too? My black picture. 360-degree turn. Where would that just get you?
Reflection, like across each.
360-degree reflection.
I don't know. Like I'm trying to explain it to you. Like
Okay.
there, and then like go around. And when that works.
I'm going to tell you, B to F is possible. It does work.
By rotation.
No, oh, yes, it can. Immediately, from B to F, you can use a rotation. But now you guys stepped up the game. Okay, you told me reflection. So use reflection.
Didn't you do reflection twice over the x-axis and then the y-axis? So it'd be
Where would the axis? If it's the axis, then here, okay, if this is the x-axis, you have to specify where is the x-axis. Where's this line that I'm going to be reflecting again? You guys are not wrong. I'm just trying to get, use your language. Eichfeld, what are you thinking? You've been sitting there.
That's all I'm gonna say, that you can just flip it once and twice and then slide it over.
Flip it once, then flip it twice, and then do another slide.
Yeah, and then slide back to where.
So are we going to call this the origin?
Sure.
Okay, so if that's the origin, we'll extend that, so where would the reflection then be?
Yeah.
So it would be, yeah, you know what,
Would it be
someone
like a
draw it
black
for me.
reflection then?
I didn't drop my marker.
Like that.
It's alright, don't worry about it.
Would it be like a black reflection?
Oh, I wonder why we did that GeoGebra investigation.
Good job, Britt.
Where would you put the line that you know that the other reflection has to go over?
Well, start off here and you're fucking over the x-axis here.
Yeah?
And then say it's the y-axis, you're fucking over the y-axis.
Okay, so then draw where you think that it would be. You can approximate, perfect. Good. Awesome. That's actually much better than
That's not a
mine.
reflection though.
So now, if I
Not a
take
reflection though.
this away, that's not a reflection? Why wasn't, honey?
Because that would be a transition.
Hold on,
No.
so
That's
from
not
here to
the
here,
sequence.
from here to here,
The arms are different.
No, they,
No, they're not.
No, we're not.
this, I erased it too soon. This,
I think it was sliding.
this was a reflection
Flip that around.
from here to here. So now they're taken from here to here. Okay? So I'm going to kind of erase my
That was
middle.
drawn differently then.
No, you were
Is that Mars?
No, you're right. No.
It was,
Yeah.
it was.
It was.
You're right.
Well, Pocket Rucker is making me doubt myself.
Pocket Rockers.
How many of you are disagreeing with Pocket Rucker right now? Okay.
It looked wrong
So,
originally.
it was probably just my image. So then now, can we take this first or this second intermediate pre-image and get it to my final image? Yeah. Hey guys, guess what? Through a translation, you're absolutely right. If I were to have taken this image and flipped it over the x-axis, couldn't I have just used that for? Didn't. Okay.
That's what I was thinking, but I didn't know the correct like term and how to word it.
How would you now word that? Now that you see it.
You put the line of symmetry through the body and reflect it over that line.
Okay, linear symmetry, vertical symmetry through, vertical symmetry through the where of the image, the what of the image.
The center.
The center of the image. We have to, in math, it's not It's not just numbers in this class, ever. It's not numbers ever in math. It's literacy, it's language. It is a vernacular. You gotta know the vocab and you gotta then use the vocab. Okay? So, I am extremely confident that you guys are competent in the trickier transformations that you're going to be dealing with today. All right, do me a favor, all of you, the individuals that I asked, if you can please hit record. Okay. 1, 2, 3. 1, 2, 3. Nope.
You should have put it on.
Is it happening? Now it's happening. Okay. 1, 2, 3. Oh, yours. 1, 2, 3, 4. Take a moment and read this, please. 1, 2, 3, 4. All. Just let you know that your hair looks great today. Thanks for doing it. Okay. All right, trickier triangle transformations. Try that on for what's that called? A homonym? What's alliteration? There we go. Okay. Read this through yourself as we read it together. There are many ways to transform an object in 2 dimensions. Some of them are to rotate it around a point, reflect it over a line, slide it along a vector, or decrease or increase its size, called a dilation. Rigid transformations are ones that do not change the size of an object. Dilation isn't a rigid transformation because it does change the size. That leaves us with rotations, reflections, and translations. To solve this problem, you can choose from this limited list of transformations, as noted below. Okay? Study the picture below. Examine how to transform triangle ABC into triangle DEF. You can use as many transformations from the list above, but be clear to show your work in each step. Make sure that you give the equation of any line of reflection, the vector of any translation, or my favorite part, the matrix used for both reflection and rotation. I forgot to make that edit. Reflection and or rotation. List the coordinates of the pre-image and the image in matrix form to defend your work. This transformation can happen in a variety of ways. Many, many different ways. How many unique methods can you come up with? Okay? Bonus. There is one way to do it in 2 steps. Can you figure it out? Okay? Before you get started, no. I know all of you are like, I'm an honors student. I need to do this now. Okay? Calm back. You can start thinking and let it churn real quick. I want you to help me out. Help us out as a class. And we're going to go through a little bit of a thought process before your individual thought process. And we've done it, in discussion before, maybe not so much on paper, but here we go. Raise your hand. What do we notice?
I have a question.
I have an answer, hopefully?
Why are the points not like A prime, B prime, C prime? What are the differences?
Because I want you to use A prime, B prime, C prime, D prime, blah, 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 to transform it into DEF.
Okay.
Okay? That was just, I don't know. Okay. So, in this task, what do you notice? What do you notice? Misto. What do you notice? Anything. Or 8. I would actually call into Amanda's question.
There's 2 separate triangles.
2 separate triangles. Okay, so you see 2 separate triangles that are similar.
Yeah.
Would they be the same triangle or
They have to be
you're trying to
congruent.
get to it?
Very good. So you know that they're congruent because what type of transformations are we focusing on? Rigid transformations, okay? Also, I think a great notice that you picked up was the fact that it was ABC and DEF, as opposed to what are we typically using with images? Primes, okay? So as opposed to A prime, B prime, C prime, okay? What else do you notice? Anything ringing into your head that you absolutely would have to use? Okay, reflection of some sort. Anything else that you notice that you're picking up right now that you have to use?
Rotation.
Why?
Because it's not facing the same direction, so you use reflection, but you also have to get it onto that side-face position.
So you know that there's going to be getting something from sideways to right up. Right, you're going to have to use a rotation and or a reflection. You're absolutely right. Good. Good, good, good. Okay, what are we wondering about? What are we thinking? What is going through your mind as you're looking at this task? Why is there a point on 0, 1? Why does 0, 1 exist? 1, 0. Thank you. 1, 0 on the plane. That's a good question. What's another one? What are you noticing? What's going through your head right now before we really get started?
No, he said, probably have to rotate it, and I said you can't.
You're probably going to have to rotate it. You said you can't. Okay, well, that's going to be a discussion that we're going to need to bring up into.
That we're not gonna be, always reflecting over an axis.
Sometimes maybe the reflections aren't going to be over the same line or over an axis. Reflections over axis compared to a line. Anything else really like striking you right now with you're not sure or that you think you'd be uncovering as you're doing this? Allie, what are you doing? You're kind of tinkering over there.
I was thinking about, can you reflect over half points?
Reflect over half points?
Yeah, like over
That's
half line.
That's a pretty good question. Can you reflect over half points? Fractions of, so rational lines? I know what you're trying to say. I'm not sure I'm communicating that very well. Basically, the points in between the actual hashtags of points. Hashtags? Crosshairs? Whatever. You know what I mean. Okay. So, how many of you are just itching right now to get started? I know you are. Okay. We are going to do a think, mini pair, big pair. Think, mini pair, big pair. Share. Whatever. So, you're going to spend 7.5 minutes-ish on your own. Then you're going to spend about 3 minutes comparing it to someone that's next to you in the group. And then you're going to talk whole group. Okay? Whole group. Next to. Oh, you're not supposed to be next to anyone. That's okay. Fine. I made Rucker and Kaylee my pocket. Pocket Kaylee. Pocket Rucker. Alright, guys, go. Work. Show your work. I'll be around. You come around with paper if you need it.
You have graph paper?
I have graph paper if you'd like it. Come up with as many transformations that you can.
We're starting from A, B, C to get to D, right?
Absolutely, that's what it says. Right on that first line. How do you get transform triangle ABC into DEF? That's okay. Extra paper if you need it. But sketch away all. graph paper, my sir. Welcome. Welcome. Any more graph paper, guys?
Yeah.
What are we thinking? We're doing okay? Graph paper?
Yeah.
Okay, you guys want graph paper? You guys are ignoring me. Okay. Anyone want graph paper? Anyone graph paper? Oh, yeah. All right, so you guys can start talking if you. It's all right. That's what I kind of heard the mumbling. So don't feel like you are restricted. Okay, just because I gave you that 7-minute time limit. If you need some help.
Yeah, I just did translation over to here.
Make sure that you're supporting your work though. If you are doing these, and I see a lot of you doing the reflections or doing your transformations first, so that's what I'm noticing, make sure that you can back it up with the math.
First of all, reflecting it, and then I was gonna.
No, I didn't.
So what are you talking about right now?
I tried to.
There you go.
Perfection. Now show yours. Let's go around the table.
Yeah, but I'm not right.
Well,
I wrote the explanation
in one direction.
Yeah.
I'm sorry, translation only happened in one direction, or can you manipulate?
Rick got another triangle.
You reflected it over as a Y.
Yeah.
Okay. So
You can, and then you just do.
okay. Why don't you work on your idea?
Yeah, but how would I fix it? Ask me again.
We're exactly like last time. There are a billion ways to do this. There are a billion ways to do this.
Well, that's why I rotated it over here, so that I could reflect it
Ideas
then.
of the rotations and reflections and translations. And just go with what makes sense to you. Cassie's way is not going to be Kara's way. I can tell you that.
Is that what
It's right here, camera. No one shoot. Oh, wait.
Did you? Oh.
Yeah, you're getting towards your good job.
No, I actually.
Good job. I heard a good job. Pocket rocker got a good job. Did you?
To the right 3.
Of course he did.
And you'll have this image. And then you.
I want you to verify this though.
Around 8.90.
So because just your drawing isn't enough.
Line, you rotate it around.
Okay.
With the book, alright, with the bonus.
Boom. I like your idea.
Like the math.
What are we thinking, boys?
Rotate it.
You translate the original image 3 spaces.
Okay.
And that would be.
Okay.
And then you rotate it around 8 prime 90 degrees.
Okay, love the fact that you're bringing the magnitude and direction. Good job.
Right in between point A and point
Okay.
B on the two triangles.
Okay, so now I think that your plan works theoretically. Can you support it and back it up now mathematically? So now with your translation, now with your rotation, then your reflection, you're bringing in 3 transformations,
If you
all of which we support through
look at this, ready?
matrices.
From this point, and it's a circular.
Okay, so grab a piece of paper, work out your plan. I want you guys to come up, see if you come up with a different plan. Okay?
No, look, it's like equal. Like the
And also make sure that like this is not
no, in a circle,
congruent.
halfway.
You make sure that it's congruent. Go for this. I like your plan. I think that your idea could work. Now you gotta support it.
Say the point is point Z. That's what I'm labeling. Point Z.
So I'm thinking that developing our plans is what a lot of you are doing first, and then you're gonna do the math afterwards. So I'm going to be putting up on the board right now some of your reference matrices, just so you can support your knowledge when you are developing your math. Okay. So let's hit F.
Now talk about the half. Alright, I'm gonna rotate around to left A over the half like this. Like Erica did. And you rotate it over A. And then translate it up 1. See how there's like the half point of the line? If you reflect over half of the line. If the line's A, D. A's 1 point off. So if I tried to reflect it over a whole, then that would work. Reflect over a half, those are equidistant to each other. And if you rotate over A, then translate up 1, they're in line.
I have a feeling that this point has to do something about rotation as the first step. Why else would it be there?
I should have these memorized and that's
Can't you rotate it 360 degrees, negative 360, whatever it is? Counterclockwise.
But you can also do counterclockwise.
Can you
I'm
do-
using it 90 as
yeah,
well.
can you do like negative, like rotate counterclockwise?
Because I see this is 7 and this is 2, so that would mean this would be 1 and this would be 6. So it would be
I mean, 180, yeah. No, that would be.
1.
Remember magnitude and direction for your rotations.
No, but I think whenever somebody has to.
Well, I'm using
This point is about those lines.
I could sign it off this way. There's different
there's
ways.
not the same size.
Alright, well, what happens if we rotate it around this pole? Where does it end?
Yeah, but.
That's what I started, yeah. And then you did.
Actually,
Like named it.
That's actually.
Like the bottom there.
No,
Bottom
Like
there.
everything that way.
And then let's do this slide up.
Yes.
so I'd be in the almost.
So C is -6 then. -7.
Yeah, I'm not saying it's the only step. It might be first.
That's the full image for that. So how do we do matrix?
Ooh, that's a big old side.
Alright, well, if we rotate, I'm trying to figure this out.
Well, I'm sorry for not providing that to you earlier.
This rotation right here is.
If
Where's
we
your notes?
rotated around point Z, where would it end?
Of course you can use your notes.
My brain is not following. It's mystery of point Z, that's what I'm looking for.
Yeah, but you also have to support it with the math.
1, 2, 3.
You're leading. You have 15
This would
minutes.
be the base of it if you rotated it.
I want you to.
Get everywhere,
Huh?
but then I won't get everywhere.
You're not going to get everywhere. It's impossible to get
What if
everywhere.
you rotate it?
Okay. So make sure you perfect your way and verify, not perfect, but verify your way.
So if you were to reflect over a half point of A,
Did it? Let me see.
The x-axis.
Just all hands up. Talk to me.
You're close enough. That would be.
But I think I know what
Like, it's like this, 180 degrees to here.
Angle right here.
Or I
and
would
then
try
We
you
are
go
trying to get
down.
ABC.
Closer to lie down,
And
and not down.
it would be
To
an
right one.
x-axis perspective. 'Cause it's not-
But could you still use your same
Well,
pattern?
you were saying that.
Yeah, but
How, using your method, do you go from A, B, C to D, E, F?
is 2 translations considered 2 steps, or is it 1? Like if it's down and over, is that 1 translation?
You could use a vector.
Okay.
Alright,
So how do you go?
Oh, yeah, vectors.
From here, you told me to rotate and then reflect, yes?
Here.
So then how do you go from here to here? And then rotate. It's the same stuff, like just in a different direction, different order. Okay. Now,
What would be the
make sure that
vector?
we're also remembering that our the main direction is always going to be counterclockwise.
Yeah, but the vector has
Counterclockwise. So if we're going to go 90 degrees clockwise, what does that do?
It doesn't make it need a vector before you can
Yeah, because you're negative.
Negative 270 with that. Or 270 degrees. Counterclockwise. Good idea, guys. Good.
I don't know, I tried.
Well,
We're at this point right here, where we rotated around point C.
first of all, I think we rotated about point C.
The first I
Point
did
C is
this.
this one. There.
Okay.
So we rotated it
The first thing that I did was this. And then I was like, wait a minute, he's not even in that. And I was
Why
like,
do you have to use it?
I'm just trying to figure it out. This is my solution. I'm just trying to figure out what it's.
Okay. So number one, is your solution her solution? Does it have to be? So for Vada, I'm telling you, verify your solution for yourself to see if your solution works. Okay? Now for the rest of you that are like, I need Z, what's going on? You don't know.
I figured out hers and I was trying to figure out mine.
Don't worry about figuring out hers. She has a brain, she can figure it out by herself.
Alright, well, I know it's right.
I flipped this over and then I was gonna try to.
So you went here to here. So erase hers and create one for yourself. Well, unless you guys collaboratively came up with it together.
Well, she came over on the time we were collaborating.
Mine has like 17 steps.
Okay.
Eventually I got to it.
Okay.
This is gonna be a pain.
Before we go collaboratively,
Yeah, work.
verify. Come up with your own solution and verify. You have to use the matrices. We are practicing with the matrices.
Mercy.
Defending with the matrices. Alright, I haven't even remembered this group yet. What are we thinking? I feel like you guys are all like independent and haven't been talking to each other. A little bit here and there. What are your thought process? What's going on in your head?
First I rotated this way and
Okay, yeah, all of your solutions are definitely different. Okay, so we'll go with my step first. What were you thinking? Okay, so if you reflect it, absolutely, I do see that your line is drawn right here at that.
I used
what's that,
4 new steps.
I don't know how to back up.
What point would you have to rotate it about in order to do this? That point. Okay, so
And
then,
is separate from right
now
here.
you're not gonna be able to verify the, you're not gonna be able to verify your,
negative BA.
Get it
Right.
back to that point though,
Isn't
without.
that like the,
with, you're not gonna be able to verify the rotation matrix.
Oh, yeah.
Okay, will that work?
have to use those. Oh, yeah.
So you have to-
Negative one.
So then now you have to come up with a way that's going to prove that it works, and if it does work, you can come up with a different solution.
You're doing yours.
Okay? Well, you might not.
She didn't do anything.
Okay.
Oh, and I know, I did it. And then I translate it, and then I get it. Got it. Okay. Should I show it?
Mhm.
Well, that helps.
Where are you going, above Z?
Okay.
Or are you just rotating on the axis?
So the reflection, then the turn, then the slide. I think this can be combined. But I like this plan. I like what you drew. So I wouldn't try and like I wouldn't try and beat the system by coming up with like, oh, well, how do I go from my pre-image to my image? Don't try and beat the system. I would say work with the system that you developed and support it.
And then I would one translate
Okay.
over one again.
Same thing. All right. Now what are you stressing out over?
XB's and triple bonds. And then do the same thing for
Okay.
C.
So the line of reflection is the y-axis. And it worked. Awesome. How did you know?
It should be the same image, just in a different spot.
I got it.
Boom. Can you say that a little bit louder? That was awesome. So that make sure you're
What are you rotating? 90 degrees, 180 degrees, 70.
awesome. That's really, really unique. And you can verify it mathematically because we aren't using the origin as the center of rotation. That is really awesome. Negative reciprocal is good.
And then you go then left.
No, that's, no. Because 90 degrees
So,
clockwise.
Your first goal was translation. So we always have to start with what? Matrix? Start with your original image, your polygon matrix.
And then
Develop your polygon matrix for triangle
with that one.
What are we thinking? Go ahead, do it out loud.
What do you think?
Okay.
I was looking for
Isn't it in that way you gotta use whatever your answer is for the first one and the second and the second and the third?
Oh, goodness. Okay, keep going. I lose track of time. Good. I love the fact that you're organizing it too. Awesome. So that's your polygon matrix. Now our polygon matrix always goes second in the order of multiplication or addition or whatever. So what's your transformation matrix? It's going to go right in front of it. What transformation are we doing? A translation. So what's happening to every single point? What's happening to A and B and C? You're adding it to 3 in the what direction? Positive, right direction, okay? So are you changing your vertical? Are you changing your Y at all? So what's your transformation matrix going to look like? 3, 3, 3, 0, 0, 0. So, please still turn your open.
Is you put the original point.
Allie, what are you working on?
Yeah.
On matrices.
You're adding, you're translating, you're translating. So in your X's and your Y's, because these rows have to match up, what are you doing to
They're
the
not, they're matching up on
3 to the right? So what mathematical operation supports 3 to the right?
right here. I got -1 and 2.5. But it's really the 1. So I think I'm gonna have to go.
Yeah. In what row?
The top of the X.
Very good. So you're going to do plus 3. How many times? Why?
To show apparently the matrix.
Points that we're moving. Okay. So now you fill in the bottom row. Okay. So now taking this matrix and adding it to this matrix that are exactly the same size dimension.
2.
Testing.
Okay, so now check A prime. Is A prime 1, 0? You're right, because you did a little math wrong.
That's where I am.
What's 0 plus 1? 1. So is A prime at 1, 1? There we go. All right, so continue. All right, ladies and gentlemen, we got 5 minutes left. Yeah, honey.
So now all I have to do is. Yeah, I actually did that faster than I thought.
Why don't you explain it to the other member of your
long
group?
step, but
And
it's
we
not
can
that
whole
bad.
group discuss it.
And then,
If y is negative x, y is negative x.
Yeah. Actually, it's
Y is negative x. So x is negative y. Y is negative x. X is negative y.
Negative
Matrix is supported. Well, because you're flipping, and this is linear algebra. Okay, mind you, this is higher. Okay, like college higher. On the main diagonal, 0, 0. It's because the main diagonal needs to be zeros because what you're doing is you're actually flipping and switching your x and your y. So if y is negative x, y is negative x, y is negative x, negative 1, 1. Y is negative x. Y is negative x. Yes. So this would be, yes, main diagonal. Okay, ladies and gentlemen. Well, I want to bring this in real quick, and I know we are running out of time fast. Does anyone feel confident or feel that they have a specifically unique solution that they find interesting that they could possibly discuss with the entire class real quick, briefly?
Pocket people. But I don't have the math for it.
Okay, you don't have to have the math for it right now. I'm going to adapt and make sure that the math is due tomorrow when you come back in class. We don't have class tomorrow. Awesome. Yay. Cool. Thursday. Okay, so I got Pocket Kaylee.
Wait, so we have to finish this?
Yeah. No, it's just because they always come up with like the
7 triangles on it.
Okay, so Kaylee, if you don't mind, right under the document protector.
Cool, now I get
Anyone else have something interesting that they would want to just share? It doesn't, whatever you find unique.
I think mine's gonna work, but I'm not sure.
Okay, then I'm gonna have you take it up there. All right, so Kaylee, take it away real quick.
What?
Louder too, girl, because.
Alright, well, I was pulling stuff up. I rotated ABC around point -1, 1. And I did that by finding the opposite reciprocals to make sure there was 90 degrees for a 90-degree rotation. And then I reflected it over the y-axis.
Yay!
That was
Absolutely.
I proved it with no help.
And she proved it with her awesome cyborg matrixy stuff, which is awesome. Love it. Love it, love it, love it. Great job. Someone else. Pocket Rucker, go for it. He is, Rucker, just noticing, is wearing a Rucker shirt. Good call, Katie.
That one.
Fat.
All right, so discuss.
Okay.
Sit it down.
So, I would multiply it over the negative x equals y axis, and then you get this triangle. And then you just translate it right to points.
Awesome. Awesome. So he's using the y is negative x line. Awesome. Anyone else? Something unique? Allie, go for it. Polly Pockets.
Okay, so I reflected over the half point right there.
X equals 1/2. No, I'm sorry, x equals -1/2. Girls.
And then I got this triangle. And then I rotated over A prime. And I got this triangle.
Direction and magnitude.
Yeah. The 90
What direction?
counterclockwise.
Very good.
And then you translate up one.
Very good. Love it. Love it, love it, love it. All three definitely unique solutions. Now, the bell's going to ring in a moment. Do not get rid of me just yet. Individuals, can you please hit your record button again, please? Alright, we all hit the record button. Alright, so wrapping up real quick. Hold on, no. Stop it. It's lunch. You guys have 10 to relax. You have an hour. So, ladies and gentlemen, we do not have class tomorrow. However, what are we taking on Thursday? Our tests. Now, I am giving back individual specific critique on all of your documents. All right, I've made my way so far to Rucker. And you're gonna see, I want you to resubmit in a different color. Study, your test is on Thursday. And you're also submitting this triangle transformations to me on Thursday as well. Love you, bye. Come on.
What do you mean by?
Wait, a different color.
You're gonna
highlight everything red?
You're gonna see,
I just added to my document.
but in a different color.
I didn't.
No, you'll see mine. You'll see.
Oh, that
where
was
they are.
fun.
I have to go back through it.
Great job. Thank you guys. Bring out always one at a time.
I already did my own break. I didn't highlight the colors because I didn't know I had that. Like on the GM, she's gonna edit on there, and it's gonna tell you what to fix because she highlighted it.
Do you think
So
this
when
is
you
gonna
fix it,
see
you gotta highlight it in like red,
solutions?
and it'll be like that's what I fixed. I didn't know that.
Cool.
I did. You're welcome.
Awesome. Thank you, Ben.
He left. I want to listen to this. He doesn't love me. He loves me.
Yeah.
Steve Allen and Erica Lickman, please report to Mr. Cash's office. Steve Allen and Erica Lickman, Mr. Cash's office. Brielle Goliath, please report to Mr.
And I love that I said there was only one way, but
Adam
it came out
Rainier,
with two more
David
different
Matthews, Sean O'Rourke, and John Rainier. Please report to student services. Josh Gillette, please report to the main office.
And he really honestly just comes out with like this stuff. I'm like, where do you store that? In your pocket? Like, what's up, guys?
So, was it a success?
It was a success. Thank you so much. My opinion.
See? Was.
I would like to show this to my class because this is not my students.
No, are you kidding? There's a reason why I picked those guys.
Yeah, but even if I pick my top guys, it's not like that.
Like sometimes even.
My problem is that we've got such a small situation. I've got 30 kids in every class.